In this video, we are going to be conquering average atomic mass. So in this problem, we have a sample of silver that contains the following relative abundances of its isotopes. We have silver 107 with an abundance of 51.84%, and we have silver 109 with an abundance of 48.16. There are two ways we can do this problem, and I'm going to show you both ways. So we'll start with 107, and you multiply that by 51.84%. And then you're going to add that to your 109 and multiply that by 48.16. Then you're going to take that total and divide it by 100. When you do that, your answer will be 107.96, and the unit is AMU. The second way we can do this problem is we take 107 and we multiply it by 0.5184. Then we add that to 109 and multiply that by 0.4816. When we do it like this, we do not have to divide by 100. And our answer is still going to be 107.96 AMU. So let's look at another problem. And this problem has a lot of numbers. So I'm going to go ahead and do it the first way that I showed you. So I'm going to start with 64. We have the isotope 64, and I'm going to multiply that by 48.63. The next isotope is 66, and I'm going to multiply that by 27.9. The next isotope is 67, and I'm going to multiply that by 4.1. The next isotope is 68. I will multiply that by 18.75. And then the last isotope is 70, and I will multiply that by 0.62. Then I will take that answer and divide that all by 100. So let me put this on my calculator. 64 times 48.63 plus 66 times 27.9 plus 67 times 4.1 plus 68 times 18.75 plus 70 times 0.62, and I equal that out, and then do not forget to divide by 100, and my answer is 65.47 AMU. And when you look at your answer, you want to see, does this make sense? So I got 65.47, which, look at all of our isotopes. We had 64, 67, 70, 68, and 66. The most abundant one was zinc 64 at 48.63%. And then the next abundant one was the 66 at 27.9%. So to come up with an average of 65.47 makes sense because it falls between those two numbers.